Okay, this is on Chromatography Lab, in which we'll be looking at the physical properties that enables colors to move through a solution and separate into its components. Materials that you'll need will include a cup or a jar, a ruler or a straight edge, tape, water, coffee filter, markers, water soluble, pencil, and aluminum foil. Okay. And so, you're going to take your coffee filter and you are going to cut it so that you can get strips out of it, like so. And then with a pencil, you're going to draw a straight line along the bottom of it. And then we're going to put your markers dotted up on it. And it doesn't take much. We just use aluminum foil as a way to protect whatever surface we're working on. Once we have this, we're going to take our cup, and it has just a little bit of water in it, just enough on the bottom. Take our handy dandy tape, and we're going to tape it onto our chopstick here. And then we're going to check to make sure that when it goes in, it doesn't touch the side too much. We just want it touching the bottom where the water's at. And now we sit back and we wait and we watch. And as soon as the water gets there, it's going to grab those particles and start going up through the filter paper. And since the particles are not all the same size, they're going to go at a different speed. This enables us to break it down to see the speed of those particles through this, essentially. And when we get done, you can see here where it's separated. Composite markers will break down into different colors, like so, and blue generally runs faster than anything else. Now, you can measure this and get what's called an RF factor for that, where we take the distance that that particle has traveled from the line to the top of where it stops, divided by the distance that the water goes. And the RF value just again tells us how fast it moved through there. Some other ideas for exploring a little bit more with chromatography, which is simply separating into its components, is trying out the food color or see what happens when you do candy. And the chem concepts that are taught in this include the idea of solutions, which is broken into two components, solute and solvent. Water is your universal solvent, and the particles that are racing through the filter paper are the solute. Solubility rules, like this all's like, if you had tried this with a permanent marker, it wouldn't go anywhere because the permanent marker is not like the water. And so the water can't pull its particles up through the filter paper. Another idea is pure substances versus mixtures. We're working with mixtures, which is why we're able to separate it through a physical means of the chromatography. Mixtures come in two types, homogeneous and heterogeneous. Homogeneous are going to look the same throughout. You can't discern a difference. Heterogeneous, they look different throughout. So your Italian dressing is a heterogeneous mixture. And again, since I'm able to separate these by physical means, it means that there wasn't an actual reaction that occurred. I can separate through physical properties and it undergoes a physical change. mixtures fall into that category of using a physical property to separate it. And again, earlier I mentioned about the RF factor. So here I have an example with the colors and showing representation about how far they've made it up through the filter paper. And so I mark the top where my water got to. And if I take from my filter paper to the top of that line, that's the distance the water traveled. That's the bottom of my fraction. And then I'm interested in the distance that each color travels, and so I mark where those occurred at. So here's my blue, and I'm going to measure from the distance that it started this race, which is that line that I originally marked at. And I get that distance over the total distance of the water traveling, and that becomes my RF factor. And again, it just tells us how fast it moved relative to the other colors. And just some ideas in case you want to try some other things at home. Maybe look at a paper towel versus a coffee filter. The candy colors is a good one. You can do that with Skittles, anything that's got a color on the outside. Food colors, and maybe try out some other markers. So we're going to end by looking back at what we have. And they're making it. And that's it on our Chromatography Lab. Try it out, see what you get.